So our last rules had us raising the same expression to different powers. What we have here is something a little different. So you'll remember before we had a to different powers times each other. We had a rule for that. We had a to a power divided by a to a power. But this is a little different. Now we have two different things that are being raised to a power, a and b to an n. And n can be any integer, and a can be any expression, and b can be any expression as well. So this is an expression that involves different things raised to a power, but these things are multiplied times each other. So our rule says that ab to the n is equal to a to the n times b to the n. However, I want to prove this, actually. There's a reason I'm doing this. Once again, it's not because this is a proof-based course, but it's because it will help if you get mixed up and you forget which rule is which. So let's see what we have here. So if I have ab to the n, what does that mean according to our rule, just from the straight definition of exponent? Nothing else. None of our rules. We forgot them all. What does this mean? Well, it means ab times ab times ab times ab a whole bunch of times. How many times in total? N times. ab times itself n times. Okay, so this means a, b, a, b, a, b, and we have this. How many a's do we have in total? Well, we have n a's, and we have n b's in total as well. And we have all of these things times each other, so we can multiply them in any order, because the order doesn't matter as long as everything is being multiplied. There's no plus sign or minus sign to distribute over. So what we can do is we can move all of the a's to the left. How many of them are there? Well, there's n a's. We already said that. And what we can do is we can move all of the b's to the right. How many are there? There's n b's. So we move all the a's to the left, all the b's to the right. And what do I have? Well, I have a to the n. By definition, by the very definition of exponent, and I have b to the n by the very definition of exponent. And lo and behold, what was this? Well, we just proved our rule. So once again, if we forget the rule completely and we run into some situation like, I don't know, 2 times x squared, and I don't remember what the rule is, what can I do? Well, I can write 2 times x times 2 times x, and this is going to be 2 times x times x, so this is 2 squared times x squared, which is a little nicer if I write as 4x squared, but I was able to do it without using this rule at all. Maybe we'll now take a look at some examples where we tried not to forget the rule and try to use it and see what happens.